Greetings, students. Welcome to Unit 5, your first video for Trimester 2. Our functions that we're working with this unit are exponential. So, exponential function, what do you ask that is? Well, in fact, that is going to be a function in the form of y equals a times b to the x power, where a is our initial or starting amount, b is our growth or decay multiplier, x is your amount of time, and y is that final amount. Now, we're going to get into graphing exponential functions in 5.4, but I want to show you an exponential function and what it looks like on a graph so you have an idea of what we're dealing with as we start getting into word problems. This is our parent function for exponentials, y equals 2 to the x power. I know it doesn't look like 1 because it has that 2, but if we made that a 1, we'd have a line. And so 2 to the x is the lowest or smallest of parent functions. What I'm going to do is I'm going to choose 6 values. I'm going to go -2, -1, 0, 1, 2, and 3. I'm going into the negatives because we need to see how it works, but I also am doing it because you've got to be careful with it being an exponential that you don't get too big. So this would be 2 to the -2 power, which if you remember your negative exponent rules, that means I'm going to kick this down to the bottom, which is 1 over 2 squared, which is 1/4. 2 to the -1 power is going to be 1 over 2 to the first, which is 1/2. 2 to the 0 is 1. 2 to the first is 2. 2 to the second is 4. And 2 to the third is 8. So now we graph these. When we're at -2, we're at 1/4. When we're at -1, we're at 1/2. And when we're at 0, we're at 1. And when we're at 1, we're at 2. 2, we're at 4. 3, we're at 8. So as you can see, this function jumps up really quickly and gets wider and wider and wider and wider and wider. And then it comes down here, and it doesn't actually ever cross. So we have what's called, as you recall, your horizontal asymptote, and that's going to be at y equals 0. That will change if you have a vertical shift, which you'll see those as we get into graphing them. Domain, as you can see, it gets wider in both directions, so we're going to go from -infinity to +infinity. And your range, it goes from 0. 0 is the bottom out point, but it doesn't actually touch 0, so we're going to use an open bracket. And it goes up forever, so from 0 to infinity with the round bracket. So don't worry about those, put that on the back burner for now. Our main focus, number 1 for today, is finding growth rate or decay rate multipliers. That means finding your B value. So it's not as hard as it sounds. If it's a growth, we're going to change that rate % into a decimal and then add it to 1. And if it's a decay, we're going to take that rate, change it into a decimal, and then subtract it from 1. So our first one is 5% growth. 5%. Remember, our decimal is right here. To change a % into a decimal, we move 2 places to the left. So this is 0.05, and then we're going to add that to 1. So 1.05 is going to be our B value. Now our next one is 6.5%. So we have that decimal in the middle already. So we take that 6.5 and we move it 2 places to the left, which is 0.065. But now this is a decay, so we will take 1 minus 0.065. And when we take 1 minus 0.065, we get 0.935. And then finally, we got less than 500, or a little more than 0.05% growth. So we take that 0.056 and we move that decimal 2 places to the left. So that means that that number is 0.00056, and because it's growth, we are adding 1 to it, which makes our rate 1.00056. Question always comes up of, can we round that? Absolutely not. You cannot round it because then you're changing what that percentage is, and every little piece of that percentage counts. Next part, telling whether the function represents an exponential growth or decay, remembering that y equals a times b to the x power is our function. So if it is growth, it's going to be bigger than 1. Decay is between 0 and 1. And that should look familiar to you in terms of it was similar to stretches and compressions with that a value in Unit 4. So we literally look at our b value. First one, 2.6, well that's bigger than 1, so it's growth. Second one, 0.76, that's between 0 and 1, so that is decay. And 4.2, well that's a lot bigger than 1, so that is growth. Yes, it is that easy. The third part for today is, can you evaluate an expression? I sure hope you can evaluate an expression. And so I need to evaluate 2 to the x for g of 1 and g of 4. That does not mean you take 2 to the x times 1 and 2 to the x times 4. It means you take 2 to the first power, which is 2, and 2 to the fourth power, which is 16.
So can you just plug it into the calculator, or do you need to show your work?
Well, that's a good question. Showing your work, I do not want you to write just g of 1 equals 2, g of 4 equals 16. I must see this middle part, especially when we get into ones like D or ones that are a little more complicated, because if you just plug it into the calculator and you get a wrong number because you type something in wrong, I have no idea how to help you. So you must write down what you're putting into the calculator before you actually do it. So here we have 20 times 4 to the 1 minus 1 power. Well, 1 minus 1 is 0. 4 to the 0 power is 1. So this is really 20 times 4 to the 0, which equals 20 times 1, which is 20. Yes, I want to see all that work. Last one, we have 20 times 4 to the 4 minus 1 power. Well, 4 minus 1 would be 20 times 4 to the third. 4 to the third is going to be 64. So now we have 20 times 64, which is 1,280. So not extremely difficult work, just making sure that you're putting everything down on paper. So now you get to try. So the first 3 are determine if the function represents growth or decay, and then tell me what the multiplier is. Then the next 2, 3, 4-ish are going to be evaluate the expressions at 2 and 5 for each of those functions. And as always, write your summaries and bring your questions with you to class.